Okay, today we're going to be talking about radical expressions. This is a new topic, but stuff you've seen a couple years ago. So we're going to begin with what you were doing a few years ago, which was square roots. So the definition of a square root is for all real numbers a and b, if the value a squared is equal to b, then a is the square root of b. So here in a simple example, if 4 squared is equal to positive 16, then the square root of 16 is going to be 4. Okay, now square roots run into some problems here because if you take a negative and square it, you'll also get the same value. So negative 4 squared is positive 16. Therefore, the square root of 16 could be either positive 4 or negative 4. So we're going to refer to something called the principal root, and the principal root is the non-negative root. So when no sign is indicated in front of the radical sign, it's assumed that we're looking for the principal root or the non-negative root. So in this case, no sign, so the square root of 25 is going to be positive 5. But if they indicate that they want the negative root, so the negative square root of 25 is negative 5. Now they may indicate that they want both the positive and negative values. So the positive and negative square root of 25 could be either 5 or negative 5. Now, when we're doing expressions, that means there's no equal sign. We're only going to indicate the root that's requested, so either the principal root or the negative root. But when we get into the equation solving unit, when you're taking the square root of the variable, we're going to state both the positive and negative values. Okay, now we're going to extend and expand in this unit. We're going to go to the nth roots. So the definition of the nth root for all real numbers a and b and any positive integer n, if a raised to the nth power is b, then a is the nth root of b. So if 4 raised to the third power is 64, then the cube root of 64 is going to be 4. If 3 raised to the fifth power is 243, then the fifth root of 243 is going to be 3. Okay, now I just wanted to write over here, if I have a square root symbol and nothing is indicated there, it's assumed that we're taking a square root. This symbol right here is referred to as a radical, so this is a square root radical. But over here, this is a cube root radical, and that's a fifth root radical. The value underneath the radical is referred to as the radicand, and the number that's stated here is referred to as the index. So typically we don't write the 2 here, but that's what's implied when you see this symbol, the square root symbol. It's assumed that this value is 2 or for squaring. But if we're taking a root other than a square root, then the value must be indicated right here. Okay, now let's talk absolute values with roots. Now, when we're looking for taking a square root, as you recall, 16, the square root of 16 could be either positive 4 or negative 4. So when taking the square root of a variable, we have to guarantee that this value is positive. Well, x by itself could be anything, so we need to ensure that the square root of x squared, which is x, is positive, so we're going to place that in absolute values. Now when we take the square root of x to the fourth, though, square root of x to the fourth is x squared. We don't need absolute values here because anything raised to an even power is automatically positive. Square root of x to the sixth would be x to the third, because we take the exponent and divide it by the index, which would be 2. 6 divided by 2 is x to the third. Since it's an odd power, and something times something times something, a negative times a negative times a negative could be negative, we need to ensure the principal root by putting absolute values around there. The square root of x to the eighth would be x to the fourth, and since that's an even power, we don't need absolute values there. So when we're taking a square root, if the root is to an odd power, we need absolute values. If the root is to an even power, we don't. Now, when we take cube roots or any odd root, we don't use absolute values at all. The cube root of x to the third is x and only x, because the cube root of 8 is only positive 2, while the cube root of negative 8 is only negative 2. Okay, so we do not want to change the values. So no absolute values when taking an odd root. So if I'm taking a third root, a fifth root, a seventh root, a ninth root, no absolute values. But now I come back to an even root. I'm taking a fourth root. The fourth root of positive 16 could be either positive 2 or negative 2. 4 negatives would make a positive, or 4 positives would make a positive. So in this case, I need to do the same pattern that I used in the squares, where the fourth root of x to the fourth would be x to the first. I need to guarantee the principal root, so I'm going to use my absolute values. The fourth root of x to the eighth would be x squared. It's an even power, so I don't need them. Fourth root of x to the 12th, 12 divided by 4 is 3. It's an odd power, so we need absolute values. Fourth root of x to the 16th, 16 divided by 4 is 4. It's an even power, we don't need them. So this is a pattern that we're going to have to learn. We only need absolute values when taking a square root, a fourth root, a sixth root, an eighth root. We do not need them when taking a cube root, a fifth root, or a seventh root. Okay, partial roots. So sometimes things don't work out perfectly, and x to the seventh is not evenly divisible by the index of 2. So we're going to break this up into the largest power that's evenly divisible by 2 and any remainder. So x to the 6th times x to the 1st would give me x to the 7th. X to the 6th we can take. The square root of x to the 6th would be x to the 3rd. But since that's an odd power, we're going to need absolute values. And the square root of x just stays underneath the radical. So absolute x cubed, square root x would be our answer in simplest radical form. Now, cube roots. Once I take an odd root, I do not want absolute values in my answer. I don't even consider them. Now, x to the 11th, 11 is not evenly divisible by 3, so we're going to break it up into the largest value evenly divisible by 3. That's less than 11. So x to the 9th times x squared. X to the 9th we can take. 9 divided by 3 is 3. So the cube root of x to the 9th is x cubed. X squared, we can't take the cube root of it because the degree is less than the index. Okay, so x cubed times cube root of x squared would be simplest radical form. Again, odd roots, no absolute values. Taking a fourth root of x to the 7th. A fourth root is an even root. So I may need to consider having absolute values in my answer. 7 is not evenly divisible by 4, and the largest value evenly divisible by 4, but less than 7, is 4. So we'll break this up into fourth root of x to the 4th times fourth root of x to the 3rd. Fourth root of x to the 4th you can take. It would be x to the 1st, and since that's odd, we're going to put that in absolute values. The degree is less than the index, so it stays underneath the radical. So absolute x times fourth root of x to the 3rd would be simplest radical form. Now, taking a fifth root, once it's an odd root, I don't need to worry about absolute values. Now, 12 is not evenly divisible by 5, so it's not a perfect fifth root, but we're going to break this up into the largest value, evenly divisible by 5, that's less than 12, and whatever's left over. So fifth root of x to the 10th times fifth root of x squared, 10 times, or x to the 10th times x to the 2nd would give us x to the 12th. I can take the fifth root of x to the 10th. 10 divided by 5 would be 2. So the fifth root of x to the 10th is x squared. The degree is less than the index, so it stays underneath the radical. So x squared times fifth root of x squared is going to be simplest radical form. Okay, we may get a square root expression like this, where I have a trinomial. Now, we cannot break up the terms into pieces. Okay, you cannot take individual pieces apart, but we can factor this into x minus 5 binomial squared. The square root of anything squared is itself just x minus 5, but since we are taking an even root, we're going to enclose that in absolute values.